Hey, how you doing? Bill Cozzolino here. We got back from vacation, 2 weeks of vacation, plus 2 weeks on the road for the company I work for, the college, and a couple of days getting ready to set this up for bench testing. You can see I took it out of the vehicle, the plasma arc generator, took it out of the vehicle, and took the plugs out. I changed the plugs about 2,200 miles, took them out and looked at them and decided to replace them. They weren't bad, but they show obvious signs of plasma arc wear. What we're going to do is take a look at the plugs. I have the unit set up on the bench. We're going to take a look at the unit, take a close look at the unit, take some readings, show you what it looks like suppressed and unsuppressed, and what we have, and you can take her from there. Okay, here we are. I don't know how well this is going to work. This looks to be about as close as I can get. I don't know how well you can see that, but these plugs do show some unusual wear patterns because of the high current in the plasma. This one here has developed a little like a slag tip, but it was still firing. It was still firing fine when I took it out. I think if we're going to run plasma hot enough to explode the water, we're going to need some probably need some better plugs. Take a look at one of these and show some eating away pretty good. Not too bad though. If these plugs are the old style non-suppressed plugs, they only cost about $10 to replace the set. So if a guy was running on just water, that wouldn't be a bad investment. Have to change the plugs more often, but what the heck, that one's got a little tip started in the anode or cathode as well. So anyway, that's what the plugs look like after a couple thousand miles, 2,300, 2,400 miles. The plugs I put in, the new plugs I put in, have more mileage on that than these do. Run them all the way back. They all run without a hitch, without a miss. I plan on leaving these in until I see a decrease in performance or it starts missing. So anyway, that's what the plugs look like. So for the trip, we got a definite. We were running just gasoline and the plasma, no water. I didn't have a chance to get the water hooked up. I know some of you wondered why I'd make this discovery, then put it on the car and go on vacation right away, but the vacation was already planned. And with a flip of the switch, I could change this back to standard ignition, so it wasn't really a big deal. I ran it the whole way without a problem. Our gas mileage increase and performance increase was actually on a 2-liter. This is basically a shoebox on wheels, so aerodynamics aren't that great, and it's 2-liter air cooled, so you know, you shift down to go up hills and stuff like that. But as soon as I put the plugs in, I live up around 7,500, 800 feet, and we come up a long road to get here. I normally had to shift down into third. Now I can walk up that hill at 35 miles an hour without shifting, no problem, no loss of speed. So there's an increase in power. As far as mileage goes, didn't get a real accurate reading before, but I was averaging 14 or 15 on the highway, and 11, 12, 13 in town, depending on how I drove. Overall, we averaged 17.55 miles a gallon on the trip. That's an increase. The best mileage we got on the flat land coming through South Dakota. 24 mile, a little over 24 miles a gallon, which is really good on a vehicle like this. So with just the gasoline and the plasma, you can see there's a definite increase in fuel economy and a definite increase in performance. Okay, for those of you who don't have a real nice shop or a lot of equipment to work with, don't worry, you don't need it. This is a setup here. We have the microwave oven transformer. We have the unit I took right out of the car. These both came out of the car. There's nothing new here whatsoever except for this wire right here, which I left in the car. I have a battery, 12-volt battery on the floor, isolated from everything. And by the way, I have a battery charger hooked up to it. When you run your test, you have to disconnect the battery charger, both leads, if you're running from shore power. I have the battery hooked up here. This is positive, goes right to the top of the coil. This is a negative. I'll move it over here to the base of the spark plug. Before we left, I put a FET distributor in it. I took the point distributor out. This is the point distributor I took out. I wanted to put it on the bench and replicate as closely as possible what happens in a car, so I'm not using a pulse width modulator for this. I'm using an actual distributor. I hooked the distributor up to a little DC motor, and I'm controlling the DC motor through a pulse width modulator here so I can control the speed. This Astron power supply only supplies that motor, nothing else. And this is a frequency counter I have hooked up to the positive, the input of the coil, and ground, so I can see what pulse frequency is on the spark plug. I've run the negative from the plasma generator, PlasmaArc generator, with a very thin telephone hookup wire. Again, I'm not seeing a lot of current draw here, so I didn't see any sense in using a big wire to the top of the spark plug. And from the ground, I go right back here to the positive 120 volts. We'll take a close look at all of these. Okay, before we take a close look and take our readings, I'm going to fire it up and show you that it works. I'm going to crank up the distributor and set the negative battery lead on the spark plug. You can see the spark beginning. I don't know if you can see the spark on the spark plug, but we're going to take a closer look at it in a minute. The PlasmaArc generator is plugged in, so I'm just going to flip this switch. And you can see the immediate difference. A little more impressive than it was on the vehicle, but let's take a closer look at that. See if I can zoom in here a little bit. Okay, let's full zoom. Now this is an old spark plug that I have clipped the cathode back so it wouldn't weld together, because I run it both suppressed and unsuppressed. There's without the plasma. And I'm getting a little mess, which is why I replaced that. But you can imagine, you can see, now that's exactly the same arc that we ran on our vacation, so you can easily understand why we got an increase in performance. It appears as if didn't notice this before, but looking at it through the camera, it appears as if I'm not getting a plasma arc each and every time, but I don't know. I think it's the distance in the spark plug gap. Turn this down a little bit. So yeah, there we go. Camera, shut her off. Disconnect the power to the coil. Turn my distributor off. And discharge this capacitor, which I do right away so I don't knock myself on my butt like I've done 1,000 times already. So let's take a closer look at it here. You can see here's the mott. Secondary is, I have a wire nut on the secondary and some tool dip on it just as a precaution. This is the negative from the 110 coming in. Doesn't really have a negative, but this is the ground side. Comes right to these diodes. And this is the hot side. Goes right to the mott. Through the primary on the other side of the primary, out to the capacitor. Capacitors across the primary and second, the input leads, and then this is the ground side, 120 volts DC ground, and this is the hot side, 120 volts DC hot. You see, I use real light telephone hookup wire, and ran this hot side to the cathode of the spark plug, their engine block. Run the ground side to the top of the spark plug. We'll take a look at that in a minute. It's my on-off switch, and this is a 2.5 amp fuse. 2.5 amp fuse. That's the smallest I could find. I got a new amp meter. We'll take some readings in a minute. I'm getting strange readings. Even though I run it fast, it doesn't seem like the meter is fast enough to give me an RMS average of this. So it's kind of subjective, other than the fact that this is a 2.5 amp fuse. So I don't know. So we'll swing this over here. So this is about as simple as you can get. I got the leads from the sorry about that. Leads from the frequency counter hooked up here. Got a little DC motor. I have a pulse width modulator pot here to control it. I've hooked it to the old distributor. Just pipe strap them down to the bench so they don't bounce around. The distributor's in here, and of course where the distributor cap is missing, so we're getting 4 sparks right to the spark plug for every revolution. This is the coil. It's just a standard Bosch coil right out of the Volkswagen. And then it runs over here to the spark plug. The ground, DC ground from the top of the diode pack, comes down here to the top of the spark plug along with it. And the hot positive 120 volts DC goes to what would be the engine ground. So that's it. That's about as simple as you can get. What we're going to do now is turn the unit on and just take some voltage readings so you can see what they look like. Set this right here. Hope you can see it, but if not, you have to trust me for what it says. Okay, across the input, of course, I got 120 volts AC. 122.2. This morning, 122.2. Okay, I'm going to switch her to DC. See, crossed here. Actually here. So from here to here. This is positive side, negative side. This is negative. I got 168.5 volts DC. From here, which is the ground side, to here, which is the hot side. And you can see it's inverted it because of the way the diodes are in there. 168.5 volts DC. Running through these diodes to the top of the output, it drops a little, 139.5. 139.5 is what we should see across the spark plug. $139.8, and that's what we see. So you've got negative 139 volts DC across the spark plug. Anode, cathode is positive. And I don't put my meter on it when it's running because of the high voltage, but I'm assuming that those readings stay the same. Now to run this unsuppressed, we don't have to take the mott completely out. All we have to do is change the output from the downstream side to the upstream side of the mott. I'm going to do that. I'm just going to pull this off. Pull this off. Put that in there. Stick that in there. I know you engineers are cringing, but you got to remember, inventors don't have to follow the rules. So there we go. Okay, we are drawing current through here. I've taken the 2.5 amp fuse out and put a 10 amp in, which is what I ran with originally. It'll blow the 2.5 amp fuse unsuppressed, so we are drawing some current. However, these wires don't seem to heat up any, so it's a bit of an anomaly. So I'm going to turn it on. You can see the spark. Let's flip it on. The reason it's kicking on and off is because the spark plug gap is so wide. It has to have a complete short here long enough to draw that current. I'm going to shut it off and close the spark plug gap a little bit. Here you get the spark plug gap closed a little more. This is liable to short itself out because it's pretty good arc. That'll blind you. Okay, I'm going to shut it off. Diodes aren't getting warm. Fuse isn't getting warm. These wires are just fine. It's strange indeed. Try that again. Probably not constant enough to gotta keep on look at that. That blinds me. Let's shut it off again. And put a different plug in there. This is an old plug, but it has a regular gap in it. You can't see the high voltage arc because it's behind the cathode. But you can see how quickly, there goes my fuse. How quickly it welds itself together, and as soon as it welds itself together, of course, it blows the fuse. So that's a lot of current through there. The plug's heating up. That time the wire did get a little warm, but I think it was because of the short. Okay, what I have in it now is one of the original spark plugs that I took out of the van, the bus. The gap is a little wide, but I think you get a better look at the PlasmaArc. I'm going to flip it on now. While I'm doing that, I'm going to take a current reading with an amp clamp across the primary input of the lot. I'm reading 1.8 amps, 1.5 amps, I think 1.4 amps, 1.5 on the input. There went up to 2, now it's 1.6. So it's less than 2 amps. I'm going to crank it up a little bit. Now I'm getting some higher readings. I'm going up to 20, 28, 14. Like I say, now I'm up to 30, 40. I don't know whether that's the spikes from the plasma, because the fuse is holding fine and nothing's heating up. So I'm going to take this same amp clamp, put it around the DC ground, going right to the top of the spark plug, and I'm getting 90 to 100 amps there. That's on that thin wire, the hookup wire. On the hot side, I'm getting 90 to 120 amps. I'm leaving it run though, because those little hookup wires aren't even heating up. Touching it with my hand now, will remain cool. I'm going to back this off here so you can see this. This is the ground wire. 400 amps, says DC, but it's pulsating DC. And if I switch it to AC, which I think would give a better reading, be an RMS. But it's about the same. And that shouldn't be. I don't know what's going on here. And down on the primary of the lot here. 40, 49, 71, 83, 69, 30, 20. Keep jumping back and forth. So, somebody smarter than me is going to have to figure out a way to find out how much current is being drawn through this thing. But as I say, these wires are showing no signs of heating whatsoever. The 2.5 amp fuse in there. And here, that's staying warm. None of the diodes are getting hot. So where's that current coming from and what's it doing? I don't know. Anyway, I'm going to have to put some engineers on this and figure out what the heck is happening. Now, I have a spray bottle for a bit of fun. And it doesn't do a very good job with this low of an arc, so we have to increase the arc a little bit. Get that straight out of it. The unsuppressed arc will explode it, so we have to get a little more current in that arc. So that means we're going to have to figure out a way to regulate that mott or some other way to adjust the current. We can see we've got unsuppressed is wide open. So it's going to be somewhere in between there. So that's what we'll be working on next. I wanted to try some water with it unsuppressed. Couldn't help myself. So, okay. I'm about half blind right now. Spots before my eyes. I would recommend that you don't look directly into that flame. It's a welding flame. Plasma arc. We have to find a way to get more current, not a lot more current, just a little more current, and able to be able to explode the water. I'm going to run some tests on this mott. I have a smaller microwave oven transformer, may have a smaller mott with less bias. I don't know. I'm just going to do some experimenting around for the rest of the day, but if I run across anything significant, I'll put it on the video before I publish it. So if not, we'll do a wrap up later. Okay, I did find a smaller mott. Physically smaller. I imagine the inductance is about the same. When I hook it up, I get pretty much the same spark arc that I did with the other one. Whoops. It's a little more consistent. Without whip. And you can see the mott is physically a lot smaller than the other one. The other one's actually still sitting behind it. I see the noise from the distributor is overriding my voice on most of the tape before this, so I'm going to fill you in on the updates here in a second. Okay, I've done current readings on the input, anywhere from 1 or 2 amps to over 100 amps in some cases. the meter pulsates up and down, even though I'm running at a couple hundred hertz. Doesn't seem to make any difference. It bounces up and down. I don't know whether it is spikes causing that or what's going on, but that's way too much current. The current has to be coming through the anode, the cathode of the spark plug right here. There is a 2.5 amp fuse in there, and these wires. Okay, we have an important update. Excuse me. After I tried the smaller mott, I found another large mott, and the secondary was bad. So my thought was to cut it apart and wind the primary wire around this piece of PVC, be able to slide this in and out, maybe to control the current. Well, I got halfway through my, no, I got all the way through my second blade and second battery, and the battery's on the charger, and I was standing around having a carbonated beverage, and I found a squirrel cage fan out of an old refrigerator that I'd taken apart, and the fan has a coil on it, of course. So I took my meter and took some readings across the coil. About 35 ohms on a couple leads, and I thought, well, that might work. That's really fine wire on one of these. So I was concerned again about the current. But the neat thing about this motor is that the core is split, so that the motor itself has a little part that just fits right into it. Okay. So now I've got a little coil with a bar that I can slide in and out. So I was wondering if it was heavy duty enough to work, and guess what? We don't have to think big. It works just fine. I'll show you. Okay, here's your close-up of the motor. You can see this was the core. Motor looked like this before I took the core out, of course. So I took it all apart and I put this in a vise and tweaked on these a little bit and worked that out, and now we have this. Pretty cool. So I've already run it, of course, or I wouldn't be here telling you about it. Thing is, I get pretty much the same plasma arc, and moving this iron core in and out makes absolutely no difference whatsoever. So we've come ahead to the point where we know we don't have to use something big, but we still don't have any control over the current at the plug. This is what's bugging me, because there's obviously very little current here, but without this in here I get maximum arc, I get full load. Changing the inductive reactance of it by moving this core in and out doesn't seem to make any difference. Size of the coil doesn't seem to make any difference. And this, of course, is the hot wire. This is 110 DC. So all that current that's happening in there isn't making anything happen in the wire. Anyway, I need some help with this because I'm not smart enough to figure it out. Now, I got a theory, so if you can't come up with something conventionally, I probably might tell you what I think might be happening in there. So here we are again. Might as well fire it up. I got the hot hooked up to the motor. On the motor a little bit. Get my spark. Oops, it's on already. So that's it. Little beef oil there. Flip it on and get my plasma arc. We'll take a close look at it. And tell me if you can see any difference. I'd like some measurements done on it. See what kind of heat output we're getting. I don't have any equipment to do that. So you can see that sliding this iron core in and out. No difference whatsoever. You see it? I'm getting that arc without even... These things are cool to the touch. There's no current going through them. That's the anode and cathode. That's the hot right there, and that's the ground through the diodes. So I'm going to need a little help with this, trying to figure out what's happening. Give you a close-up of that here. Ain't she pretty? That's a pretty wimpy spark to start with, which is why I replaced that thing. Okay, I'm going to play around a little more and then we'll do a wrap-up. Okay, this is going to be a wrap-up. I have done a little more playing around and I'll tell you what I did. I didn't tape it, so went down to Walmart and I got a 100 watt excuse me, 100 watt inverter. 100 watt is less than an amp. I think it's like 0.8 something, almost 9/10 of an amp. And I hooked it up to the battery through this current bridge. This current bridge is 100 millivolts equals 100 amps, so 1 millivolt would equal 1 amp. Thinking that I could actually get the current reading at the source rather than trying to get the current reading for the AC, which we were having a problem with. We were seeing a draw of current in the AC loop, and still not popping this 2.5 amp fuse. Strange things. Well, that worked. That worked perfectly until I shut it off. And while it was working, I put the meter on it. It showed a draw of initially a draw of 2 or 3 milliamps, and then as the unit continued to run, it dropped down to like just a couple milliamps, and then it went negative, as if it were putting energy back into the system. Now this is something really weird, and unless it's being caused by the spikes of the plasma, I can't tell what's happening. The unit ran great. It gave me the plasma arc just like before, just as strong. Virtually no current draw through the inverter. Like I say, the readings were strange. And then when I shut it off, the inverter now shows a fault. That's a blinking red light. The documentation doesn't tell you a lot, but it's not putting out AC anymore. It's a pulsating AC. It's turning itself on and off as if there were too much current draw. And while it's on, it's causing the plasma arc. While it's off, it's not. I'm going to plug that in and just show you what it looks like. It's weird, but we'll take a look at it. Okay, I don't know whether you can hear this running or not. It's the battery. It's running the little less than a watt inverter. See the lights flashing on and off because it's in fault now. And it's running through this current bridge. I'm drawing 0.1 to 0.2 milliamps, which is 0.1 to 0.2 amps. So what I'm going to do, when the green light is on, it's producing AC, and when the green light is off, it's cycling. So it's cycling on and off. Like I said before, when I first turned it on, it ran perfectly, and it didn't quit till I shut it off. I ran it for about 5 minutes, so it was working good, and I took some current readings. So I'm going to plug in the plasma arc now, right straight to this. See, it's still pulsating on and off. Turn this unit on. Of course, it's drawing no current now, so it's still pulsating on and off. I'm gonna find my meter, my other meter. I'm going to take a DC voltage reading across the plasma generator. Get 146 to 150 volts DC. Of course, the capacitor is holding the voltage up as the inverter is cycling on and off. And I'm going to turn on the distributor. Hold on a sec. Loose wires. I'm going to turn this over now onto the spark plug so you can see what it's doing. It's intermittent. It's a buildup of voltage. Okay, now I'm going to turn this back to the bridge amp meter. You see now that we're drawing what looks like negative current. Turn the plasma generator off. Disconnect spark plug, the alternator, and it goes back to 1 to 2/10 of an amp. So those readings can't be good. And I don't know what else to do to get better readings. So that's where we are. One of those days. So I know you're going to say that the pulsating plasma arc is the capacitor discharging, and I'll agree with you. That's what it is. Capacitor is being charged up and it's discharging. Current draw is an anomaly though, and the capacitor is a dipole. You can't get electrons to flow through a capacitor. They have to come from the energy around the capacitor. They have to come from the energy around us, the energy that's inherent around us. And actually the battery is the same way. The battery is a full dipole. The electrons appear to flow from positive to negative, but what we actually do is create a dipole on the other end and then immediately destroy it. With this system though, we have a dipole that's created across the spark plug by the high voltage, and we have a dipole that is the exact opposite of that, created across the spark plug. That's the low voltage high current. So those are two dipoles interacting with each other. The current is coming from the energy source around us in the capacitor. This spark plug is also a capacitor. It also contains a dipole. So we got that dipole, and that dipole that we're working with. That gives us some different things to look at. But like I say, we really need to put some engineers on this and get some better readings and find out what's going on. I'd like to put this back in the car, but I'd also like to wait until we have a little better way to control the current. I know you come up with some electronic way to do it, but I really prefer to stay simple. If there's a way to do it mechanically by stretching or compressing the windings, by inserting a core into it, by changing the inductive reactance with some DC, something that is mechanical, I think would be better in the long run. This is an electromechanical universe. We don't often think about mechanical things when we look at electrical things, but energy and matter are two forms of the same thing. So we're talking about both electrical and mechanical when we're talking about electricity. I've always had a problem with E equals mc squared, and it basically means that energy and matter are two forms of the same thing. What's here is there, and what's there is here. And if they are, then they should follow the same rules. I don't like using constants. When you plug in a constant, you're trying to make the universe conform to what you think it should be, or work the way you think it should work. So I would completely stay away from constants. The rules that work here in the physical world should apply in the energy world. It's just, if E equals mc squared, that's just the way it should be. I would like to put it back in the car, but like I say, I'd like a way to control the current, and I'm asking for your help on that. I also would like to add some HHO to it. HHO definitely enhances the combustion of gasoline. There's no reason to assume why it wouldn't enhance the combustion of water as well. So with a couple liters of HHO going in along with the water, I think we might see some really nice effects. I don't have a HHO generator here. I've been working on them, and I've built a couple, but nothing that'll give me a couple liters a minute at 20 amps. So if anybody could help out with that, that would be great. As far as the engineers and the forums, I apologize for not being on the forums. I do read them to see what's going on, and actually to see if there's any questions that come up that I haven't already answered. So far there haven't been. I'm being completely honest with you, and I'm showing you everything I've done. You can look at it and you can theorize about conventional electronics and formulas. That's okay. But really the important work will come when you actually replicate what I've done and start playing around with it. And I encourage you to do that. You're not going to make those discoveries until you find out what's going on here. There may be a conventional way to explain it. I just might not be smart enough to do it, and that's fine. But really we need to put some time into it. This is a consistent plasma arc. I've run it 4,500 miles plus on the Volkswagen with absolutely no problem whatsoever. A little extra spark plug wear, but spark plugs are cheap if you can run on water. The problem is figuring out what's going on, and we're going to have to work together on that. I'm not an engineer. Ash made the and I thank Ash for calling me an engineer, but I'm not an engineer. I have a very high mechanical aptitude, extremely high mechanical aptitude, and I have a background in electronics, and I see the universe as an electromechanical system, an interacting electromechanical system. I don't see it as energy over there and matter over here, and we need special rules for both. So when I look at something like this, if it doesn't make sense mechanically, I've got to work it out mechanically before I can go ahead with it. And I encourage you to look at the mechanics of it as well as the electronics of it. So we've got a lot of work to do. We actually have, with this system, we should be able to get an engine to run on just water fairly easily. What was missing up till now was a consistent plasma arc, and we have that consistent plasma arc. All that's necessary is to replicate what I've done and tweak it up a little bit. So we're there. It's just a matter of putting everything together and making it work. I'm not asking money for any of this information, and I never will. The videos will always be free to watch. The information will always be free to download. You could help us out here by purchasing the download package from skyhero.com. You're going to get the same information, but the difference is that you'll have the video on your desktop. That's not a big plus, but there's some other stuff to download there as well. There's my book, The Path, and there's some binaural sound files that work real well for meditation. Kind of may help you think outside the box a little bit. Things are changing rapidly in our world, and we're approaching a time of change now. I can't tell you how nice it is. It looks nasty on the surface, but it's just birth pangs. You want to call it birth pangs. Just a very few years from now, what we will be able to know and understand about the world we live in and our relationship to it will be light years beyond what we think we believe now. That world is opening up to us, and it's going to take some time. It's going to be a rough journey for a lot of people because it's a tremendous paradigm shift. But if you start thinking about the implications of E=mc squared, if energy and matter are two forms of the same thing, and we say, most of us believe that we're not just a physical being, we're more than that. Well, if energy and matter are two forms of the same thing, we're not just an energy being either. We're more than that. And there's a possibility that our essence has no part of either energy or matter. And that carries some profound implications as far as the world we live in and our ability to interact with it. So keep working on it and keep in touch. I may do a few more show and tells. I'd like to put this in and with your help, working on it, get it so we can run ICEs, internal combustion engines, on water. But I see this same dipole principle in magnets as well, and I would really like to get this wrapped up and move along to magnets. There's as much free energy in magnets as there is in what we're seeing here. So anyway, keep up the work, keep in touch through Ash. I won't spend a lot of time on the forums. If there's questions that have been asked that I haven't answered, I'll certainly answer those. But as far as discussing formulas and stuff like that, unless we can clearly show in a conventional way what's happening here, then we need to look elsewhere and think about some different possibilities. Keep in touch with Ash. Oh, by the way, the squirrel cage, I mentioned on the video that was a squirrel cage fan. It's actually a squirrel cage motor. The fan had blades. The squirrel cage fan is what it was, and any squirrel cage, actually it looks like any inductor will work. Every inductor I've tried a large amount, a small amount, and then this squirrel cage fan. Very fine wire on that fan. There's no heat generated through that at all. It just shows no signs of current draw whatsoever. That's pretty phenomenal. So it's just a squirrel cage motor winding. Actually, all it is the inductor. So I'm thinking that any kind of inductor you can find laying around might just work, and I encourage you to plug one in and try it. You're not going to do anything more than blow a fuse and maybe weld a spark plug together. So give it a try. Like I say, I've got a few more things to show you, and maybe some things to tell you if we have the time. If we get out of touch, time will come when we'll be back in touch. So hang in there, and good fortune in your work.